Right, yesterday we worked with sums and products formulas. Once again, I will give you all those sums and products formulas. You will not be responsible for memorizing those. Questions you have, a lot of just working through fractions, dealing with the fractions and working through the fractions, anything we need to go through. All right, we're going to deal with the last section in this chapter. Once again, it's nice to get through this chapter because there's three chapters that we have to cover in trigonometry. The middle section is very similar to the middle part of our trig class that you took, if you took it prior to this, where you had to deal with trig identities and all that stuff. A little bit more difficult, a little bit more challenging, a little bit more work involved with it, where the first and the third chapters aren't as difficult to deal with. We will eventually get into law of sines and cosines and do all that kind of stuff at the end in the next chapter. As we've talked about before in the other class, my class here, this class here it's like a cosine curve, okay? Not very difficult, a little bit more challenging, and then we ease back out of that again with respect to difficulty level. Today we will deal with solving equations. Okay, this is one thing that we did not really do much of as we went through the sections of angle addition, double angles, half angles. We didn't do much solving equations. We will do that now with respect to solving the equations. When we deal with the inverse trig function, inverse sine, inverse cosine, inverse tangent, it allows us to solve for an angle. Whose sine, cosine, and tangent are specific values. When we use our inverse functions, and on your calculator, you have the inverse functions on your calculator, it allows us to solve equations. It allows us to get rid of sine, cosine, tangent. Once again, in mathematics, you have mathematical processes that we will continue to do. For example, we have squared numbers. We'll eliminate to undo the squaring of numbers. We can square root. Well, to eliminate an x squared, we can square root. If we had the equation x plus 1 quantity squared is equal to the value of 16, we could solve this equation by getting rid of the square by square rooting both sides. So we have x plus 1 is equal to plus or minus 4. We have two solutions there. And we can solve our equations. Those are undoable processes. When we have mathematical processes, we also have mathematical undoable processes. When we have 10 to the x is equal to the value of 20. We can undo this 10 to the x by taking the log of both sides, because that is the undoable process to 10 to the x power. Okay, so every mathematical process, you have undoable processes. If we multiply by 5, we can divide by 5. We have 2x is equal to a value of 20. We want to solve this equation. We have multiplication. We can undo the multiplication by division. And that's true with respect to our trig function, sine, cosine, and tangent. If we want to get rid of sine, cosine, and tangent, we can do the inverse of sine, cosine, and tangent and be able to eliminate the process of sine, cosine, tangent. Okay, principal value. When we deal with a principal value, that is your calculator value. That is your calculator value. If we have the sine of theta is equal to 1/2, and we want to solve for theta, well, what is connected to this value of theta is the sine function. Well, as we just talked about up here, to undo the sign, we can inverse sign both sides. The inverse sign and the sign gets rid of each other. Just like when we have multiplication by 2, we can divide by 2. It gets rid of that multiplication by 2. Or when I have a square, I can square root. Or if I have 10 to the x, I can take the log of both sides. Or we can take the inverse sign that gets rid of the sign. So now we're left with the inverse sign of 1, 2. Well, in our calculator, we can sit there and clickety-clack in our calculator. Correct mode. In a degree mode, I can take the inverse sign, and you can take the inverse sign of 0.5, close your parenthesis out, hit enter, and you get the value of 30. That value of 30 is called the calculator, or the principal value. It's the value that you can come up with respect to out of your calculator. Okay, that is the principal value. When we deal with principal values, inverse sine will be in between negative 90 and 90 no matter what. Inverse cosine between 0 and 180, and inverse tangent negative 90 to 90. Those are the values that you can come out of your calculator. But the problem you run into is if we take the sine of 30, we get 1/2. What I want you to do in your calculator, I want you to come down or take the value of the sine of 150. And the value you come up with is still 1/2. If we would take the sine of 390 degrees, you still get 1/2. Well, we have developed in our brain that the calculator will always give us the right answer. Why? Because it's the calculator, and the calculator is smarter than our brain. Okay? No matter what, even if it's the wrong answer, that's the value I get in my calculator. That has to be right. That has to be correct. Why? Because it was in my calculator. And the calculator says that's correct because I did it in my calculator. Well, we got one solution from the calculator of 30 degrees, which is a correct solution. But there's an infinite number of solutions that you can come up with respect to the sine of theta is equal to 1/2. I can just continue to list values here, and that will give us values that will give us a value of 1/2. So the calculator, yeah, gave you 1, but how do we get all the values, that infinite number of values? Well, when taking the inverse sine and inverse cosine, you get 2 solutions. You can come up with 2 solutions. Just like when we had x plus 1 quantity squared is equal to 16, we could take the square root of both sides. We get 2 solutions. X plus 1 could equal positive 4, or x plus 1 could equal negative 4. So that gives us x equals 3, x equals negative 5. If I would put negative 5 in here, add 1 to that, I get negative 4. If I would square that, I would get 16. If I would put 3 in there, I'd add 1 to that, I get 4. I square that, I get a value of 16. Well, just like when you take the square root of both sides and you get 2 solutions. When you take the inverse sine or cosine of both sides, you get 2 solutions. Okay? When dealing with the inverse sine, You get that principal value, which is your calculator value, but you also need to deal with its supplement. So you have the principal value and its supplement. Well, if I take the inverse sine of 1/2, I get 30 degrees. That's my principal value. Well, the supplement to 30 degrees is what angle do we have to add to 30 to get to 180 degrees, which is 150. That's why they have a sine of 150 is equal to 1/2. When dealing with the inverse cosine, you have its principal value, but then you have the opposite to the principal value. You have the principal value and its opposite. That will give us our two solutions. Because if we have cosine of theta is equal, we'll go back to 1/2, and we take our inverse cosine of 1/2, we get a theta value of 60 degrees. So if I would take the cosine of 60 degrees, we would get 1/2. And that's our principal value. But if I would take the cosine of negative 60 degrees, take the cosine of negative 60 degrees, the opposite to this, we still get our 1/2 or our 1/2. That's that odd or even function. Even function, cosine's an even function. So if we have the cosine of 60, that's going to equal the cosine of negative 60. Cosine of 120 will equal the cosine of negative 120. We deal supplement of an angle. We can just subtract when we're in a theta mode, we can subtract from 180. And when we're in a radian mode, we have to subtract from pi. The first fly of the year. We need the salt gun. Has anybody ever used the salt gun? Does it work? If you have good aim?
You gotta be pretty close.
You gotta be pretty close? To me, that's still...
I don't know, that might not be allowed in school, though. The salt gun. Being a gun at all.
That's true. A facsimile of a gun. Solve equations, general solution, and leave in terms of pi. Now, when we are in a radian form, you have two choices that you can make. You could do or deal with this in terms of degrees and radians, or you could deal with degrees, or you can deal with radians, or you can put things into degrees. My suggestion to you, this is my suggestion, you leave your calculator in a degree mode initially. Because what we want to solve for, we have the sine of x plus pi over 3 is equal to 1/2. And we want to solve this for x. So to get rid of our sine from both sides, we can take the inverse sine. And if you take the inverse sine of 1/2 in the radian mode, you're going to come up with a decimal. Well, we want to try to leave things in terms of pi. So what we can do is keep it in a degree mode. what is our degree measure for the inverse sine of 1/2? And a degree mode, that's equal to what? 30 degrees again. So that is equal to 30 degrees, which hopefully we know by now that's our pi over 6. So we have x plus pi over 3 is equal to pi over 6. But when we take our inverse sine, we get our two solutions. We have the principal value, which is our calculator value. Okay, we just came up with that 30 degrees. We also have its supplement. Now you can deal with the supplement as by subtracting pi, this off of pi, or you can deal with this, well, what's the supplement to 30 degrees? 150. So we have a supplement, which is 150, which in terms of pi, this is where it's nice to know these. Pi over 3 is 60, pi over 4 is 45, pi over 6 is 30. And you ask yourself, which one of these can I multiply by something to get 150 degrees? Well, 60, I can't multiply it by anything to get to 150, 45, nothing. But 30, I can multiply by 5. But what I do to one side, I do to the other. So 150 is 5 pi over 6. So my second equation is x plus pi over 3 is equal to 5 pi over 6. To solve this, we need to subtract pi over 3 from both sides. For us to be able to subtract fractions, we need to have a common denominator. So pi over 3 we can rewrite as negative 2 pi over 6. Multiply the top and bottom by 2. Minus 2 pi over 6 over here. So what we're left with is x is equal to negative pi over 6. And over here, x is equal to 3 pi over 6, which is pi over 2. Now, if you want to leave in degrees and then convert it back into radians when you're done, that is fine. If you want to say this is 60 degrees, this is 30 degrees, I subtract 60 over, I get negative 30. So we have negative 30 degrees here. And then convert back into negative pi over 6, that is fine. If you want to leave this as 150, and I'm going to, then I have 60 here, and I'm going to subtract 60 from this, I get negative 90, positive 90. That gives me pi over 2. That is fine. At some point, you're going to have to convert things back into radian form. If you want to deal with it in radians to begin with and keep it there, that is fine. If you want to keep it in degrees and then at the very end, convert it back into radians and turn to pi, that is fine. You choose what is more comfortable with you or for you. I'm going to ask for general solutions. Up here, I went 30 degrees, 150 degrees. I can still get 1/2. Then I went 390 degrees, I still get 1/2. If we did 510 degrees, we still get 1/2. What we're doing when we continue to get additional values, when we have our general solutions, we have our principal value, we have the supplement, and to get these general solutions, we add or subtract any factor we want of the period. So we add or subtract any factor of the period. Likewise with the inverse cosine, we have our principal value plus or minus Pn, and then the opposite plus or minus the period n. And this will give us our general solutions. So if we look down here, we have our B values, a value of 1. So the period is going to be 360, which is 2 pi. So we can add or subtract 2 pi and add or subtract 2 pi n. So these are our general solutions. Cosine pi x plus pi over 4 is equal to square root of 2 over 2. Need to get rid of cosine. To get rid of cosine, we can inverse cosine, so we can take the inverse cosine to square root of 2 over 2. Need to watch your parentheses. Or you need to make sure you pull out of the radical if you have a newer calculator. Because if you have a newer calculator and you don't hit your right button to get out underneath the radical, you're going to get the square root of 2 divided by 2, which is square root of 1, which is 1. Will give you a mistake. You have to hit your right arrow to get out of the radical. So we take the inverse cosine and square root of 2 over 2. In degree mode, what do we get? 45. So we have x plus pi over 4 is equal to 45 degrees. We take the inverse cosine. Inverse cosine, we have also its opposite. So we have x plus pi, or pi over 4 is equal to negative 45 degrees. Once again, we have degrees and we have radians here. You have to make a choice what you want to do. Do you want to try to solve everything in degrees and then convert it back into radians? Or do you want to solve everything in radians and just, you're done? (45 degrees) is pi over 4. And negative pi over 4. We have to subtract our pi over 4 here, subtract our pi over 4, subtract our pi over 4, subtract our pi over 4. These here are opposites to each other, so we have x is going to equal 0 plus or minus the period n. Here we're going to get x is equal to negative 2 pi over 4, which is negative pi over 2, plus or minus the period n. Our b value here is a value of 1, so the period is going to be 360, which is 2 pi. So we have plus or minus 2 pi n, plus or minus 2 pi n. These are two general solutions. The hope is, as we are going through this, you have some recall back to what we did when we were in trig class. Sine of x, sine pi over 4, plus cosine x sine pi over 4 is equal to 1/2. Now what we need to do is go back and recall our angle addition formulas. Where A is our x value, B is our pi over 4, A is our x, B is our pi over 4. Which one of our trig angle addition formulas was sine A cosine plus cosine sine? Sine of A plus B. So we have the sine of A plus B. So this takes us back to sine of x plus pi over 4 is equal to 1/2. Okay, take your inverse sine of both sides. Now we're going back to what we just did on the front side. Take your inverse sine of both sides. And once again, you need to figure out what works best for you. Do you want to keep everything in a degree mode and convert everything at the very end? Or do you want to deal with this, find your inverse sine of 1/2, which is 30 degrees again, and convert that into a radian mode, and then work with your fractions? Once again, either way is correct. Either way will get you solutions here, okay, that you need. You just need to figure out what works best for you as you go through the problems. Because as we talked about, there's more than one way to get to Worcester, and there's more than one way to get to a solution here. So we get 30 and 150 there. And if you want to take this back into pi over 6 and 5 pi over 6 and work the problem out from that point, that is fine. And just work with your fractions. It's not that bad dealing with fractions. But if you want to put it all, keep it all in degree mode and wait to the very end to be able to convert it out, that is fine also. Your conversions tend to be a little bit more of a challenge, but it's doable.
Mr. Gregory?
Yeah.
How do you get that 1/2?
How do I get what?
For the second equation out here.
Okay, so this is our principal value. We took the inverse sine, we get two solutions. Inverse value, inverse sine, we get our principal value. That's what we got from our calculated value. But then we also have to deal with the supplement. Well, what's the supplement? We came down to 30 degrees. This is our principal value. What's the supplement to 30 degrees? Well, we could take 180 and minus the 30 to get us 150 degrees. Typically what I do when I have this, I work with fractions here. And I just convert them into common denominator of, let's see, 4 and 6, we'd have 12. So we have 2 pi over 12 here. And minus 3 pi over 12 here, multiplying top and bottom by 3 and 2 here. So I can just add and subtract my numerators. So we have negative pi over 12. And negative 1 pi there. And these values right here at the bottom is going to be the same. So we have negative 3 pi over 12 at the bottom. On top, we would have to multiply the top by 2. So we'd have 10 pi over 12 there. So we have 10 pi minus 3 pi. That gives me 7 pi over 12. Plus or minus the period end. Well, our b value is still a value of 1 here. So we have 2 pi n, 2 pi n is our solutions. Once again, if you want to keep it 30 and subtract off 45 degrees, we have negative 15 degrees, and that negative 15 degrees will convert back to negative pi over 12. And likewise over here, if I subtract off by 45 here, we would get 105 degrees. And if I convert that back into radians, I'd have 7 pi over 12. Once again, that's a little bit more difficult of a conversion for me to look at, but it's still doable. I'd rather deal with my fractions and just work through my fractions. That's just my own personal thing. If you want to go with this and deal with this, that is fine. We have sine squared minus cosine, or cosine squared minus sine squared is equal to square root of 3 over 2. Once again, now we have to go back to what's cosine squared minus sine squared. Cosine of 2x. So we have cosine of 2x is equal to negative square root of 3 over 2. Okay, this goes back to our formulas. So now we go through the exact same process. Take your inverse cosine of both sides. We get two solutions. But you have to watch yourself because now we have 2x is equal to these two values. Okay, watch your negative sign in there. Don't lose your negative. We have negative square root of 3 over 2. Inverse cosine negative square root of 3 over 2, what do we come up with? 150. We have 150 here. Inverse cosine, we have a second solution, which would give us negative 150. Now, once again, if you want to take this to 5 pi over 6, negative 5 pi over 6, and work through it that way, that is fine. We have to divide by 2. So x would equal 75. Here, x would equal negative 75. If you dealt with this in radian form, dividing by 2 is like multiplying by 1/2. So this would give me 5 pi over 12 and negative 5 pi over 12. Our b value has turned to the value of 2. So we have 2 pi divided by 2 now. So the period is going to be a value of pi, or 180 degrees. So we have plus or minus pi n, plus or minus pi n. And once again, if you want to take 75 degrees and then convert that back into Pi over 180 is equal to x over 75. Multiply by 75, we have 75 pi over 180. Once again, your calculator will reduce your fraction for you. If we have 75 divided by 180, hit your math button, hit enter. That will take you back to your 5 pi over 12. So your calculator will do that for you. You have to, once again, find what's good for you and work through the problem then. We will spend a few days with this. I know these tend to be a little bit more challenging. So don't feel that this is a one and done like we just did with the half angles and some of the products formulas. This is not one and done. We got work some today. We will be dealing with this tomorrow and also Friday. Because once again, this is a little bit more of a challenge. And as I said, you have to find what works for you in regards to solving and dealing with the radians and dealing with the degrees. You'll get there either way. It's a matter of what you see and what's easier for you in your brain and to work with in your brain. All right, solutions have been posted for you. And the rest of the time is yours.